Example 4.11 or 5.11 for the given textbooks. For details, please see the description below. In this example, we need to determine the enthalpy of liquid water at 100 Celsius and 15 megapascals by using a compressed liquid table, by using the approximation as a saturated liquid, and by using the correction given in this formula. To determine the enthalpy using the compressed liquid tables, we go to table A7. We looked at the pressure, which is provided to be 15 megapascals, and we go to a temperature of 100, and we go across to the value of the enthalpy, and we see that the value of the enthalpy for these conditions is equal to 430.39 kilojoules per kilogram. Part B is asking us to find the enthalpy by using the approximation of a saturated liquid. To do so, we go to table A4, which is provided in terms of temperature. We go to the value of the temperature, we go across, and we find the value for the enthalpy of the saturated liquid, and that gives us 419.17 kilojoules per kilogram. These are the solutions from part A for part B. Part A is the exact solution since it comes directly from a compressed liquid table. Part B is an approximation. Notice the difference between them. The main reason is part B, it only encounters or takes into account the temperature of the process. However, if we use the correlation provided in part C, notice that it provides a correction due to the pressure difference. If we go back to the table, we see that the saturated pressure at the 100 Celsius was 1.142 kilopascals, and we find that the value of this specific volume at that temperature of 100 Celsius is equal to 0.001043 meter cubed per kilogram. So now we're going to use these values into this correction. Now please remember, this correction takes into account the difference between the saturated pressure and the actual pressure that takes place in the process. So this is going to be enthalpy that takes into account the pressure and the temperature, and that is used by using the approximation that it was found in part B plus a correction F at that temperature, the working pressure minus the saturated pressure at that given temperature. Okay, so these are the values we have. We have 419.17 kilojoules kilogram, plus we have 0.001043 meter cubed per kilogram. This is 15 megapascals, so it's 15 e to the 3 kilopascals, minus the saturated pressure, which is 101.42 kilopascals. If we solve this, we find that the quantity is going to be 4.34.71 kilojoules per kilogram. By comparing the values, we said the value of A is the exact solution. The value of B is an approximation that only takes into account the temperature of the process. This gives us about a 2.6% difference. If we use the correction, in which includes the pressure of the system, we find that the difference is about 1% from the exact case.